Hey everyone, so this is following the previous two videos where I taught you, or hopefully taught you, how to CAD your first ever model and to use dimensioning constraints to your advantage and to navigate the Onshape UI. And so for this video, I think we'll go through assemblies, which is actually really important for robotics just because when you're designing multiple parts, usually for things like, a gripper, for example, like we designed last year. There are a lot of moving parts that need to come together. And the assembly, which you see right here, the assembly is where everything comes together and you can see how everything interacts with each other, how parts can fit together, and if you have to make any other adjustments to your parts. So right here, this is actually not made by me. This is a Onshape exercise that you can actually visit if you search up Onshape tutorials. But this is sort of, I'll go through how I sort of do this um, um, and put together this assembly. And so if you take a look at the part studios, so remember, these are called part studios and these are called assemblies. And so within the part studios, you see that someone at Onshape must have made these three parts. And so although they look fixed, and they kind of are in this regular part studio, if we make a new assembly, remember, click the plus and you can create a new assembly. Um, and when we insert a part, and you do this by going to insert. So you insert and you select the part studio that you want to insert, click on the main the main canvas, and then click enter, or the check mark, sorry. And so that puts your part into your assembly. And so if you can see now, there are no mate features. We'll describe what mate features are in a little bit. Essentially, that means that there are no connections made. So you can see that I can pretty much freely move around this part and this part as well. They're free, they are not connected. They are not connected using these mate features. And so what you see on top, these are very more advanced features for assemblies, but you really only have to focus on a few, and it is these mate features right here. And so these all do sort of slightly different things, and we can probably first go through the fasten. So in general, this removes all degrees of freedom between two entities, which just means it's fixed. You cannot rotate it anymore. And so if we click on the fastened, it will ask for things called mate connectors. And so mate connectors, if you can sort of imagine, if I'm hovering over a certain part or face, you can see that there are different places where this sort of compass looking object appears. And that is called a mate connector. And there really isn't sort of like, I'm sort of struggling on how to describe what a mate connector is. It's kind of just a point on the face that you sort of select. And so in this case, we want to align, for this assembly, we want to align this side of the bar to this, the inside of this bar, or this inside of this sort of clamp. And so what you should be doing is first sort of you want to find the first mate connector that you want. And so we don't want this outside face. As you can see, if we if we move around, you can see that we're selecting the outside of this, this sort of rim, the surface of this hole. And we want instead to connect the inside. You can see that that interface is now selected. But when you're hovering over a face, you want to always press Shift, and this allows you to lock the face when you're to find a mate connector. So instead of, if I let go of space, you can see that my mouse is traveling freely across the screen and exploring where the mate connectors are in other faces. But when I select this face and press and hold Shift, you can see that even if I move off the face, it's still trying to find the mate connectors on this face. And this is a really useful thing. Always press Shift when you selected the face. So in this case, I want to select this interface right here, right over here. And so I'm going to press Shift and hold Shift. And this allows me to move around this face freely. And it already gives me the center point right here. I'm going to click this point right here. And it's going to tell me that I selected the mate connector of this part. And the face that I selected is highlighted in yellow. And what we're going to do is align this with this rod right over here. So again, highlight the face, select shift, press and hold shift, and you'll be able to select the mate connector. Again, it's pick the center right here. And so what we're going to do is to click this, and it will automatically pop up, make another pop-up, and all you have to do is click enter, or not enter, click the check mark. And there are other features like flipping the primary axis, which sort of rotates the part. Same thing with the secondary axis, it flips the part around. But in this case, everything is aligned perfectly, and thus we have to just press enter. So that is our fasten mate. If you can see right now, when I move this part around, it is completely fixed. And you can't rotate it. And so it's fixed permanently there. If you want to delete things, you can always come here and delete or suppress your mate feature. So what I like to do is just, because it's a solid assembly, is to always fix a part. And so what you mean by fixing is you go here, you right click, and you press fix. And this essentially makes it so that this part is actually now fixed in space. If you try to move it around, it will have that fixed icon right over here. And so you can't move it around. And this allows, you might run into some errors if you don't fix a part to your assembly screen. If you don't fix it to the canvas, that may happen. Some rotates might sort of freak out. And when you want to rotate a part, it might actually end up moving the whole part instead of rotating it. So you have to fix one of these parts. So this next part, right over here, the one that's I'm hovering over right now, we're actually going to use a slider mate because this is, I think, it's a clamp. This design is actually a clamp. And so if you look at the top bar over here, you're going to see a slider mate, and we're going to select that. And so essentially this slider mate, it's pretty self-explanatory. It allows an object to slide up and down another object. In this case, we're going to select a very similar thing. We're going to select this face, again, press shift, and we're going to select this middle part again. So click, and then over here, we're going to select this part again. It's going to automatically make that. If you press shift again, it will automatically generate the center for the mate connector, and we're going to press it again. There we have it. That is our slider mate. And now if you try to slide it, it will slide up and down right there. And if you change the perspective and we try to drag it sideways, it's only going to go up and down the bar. And so that is a slider mate. And like I said, I just wanted to show you this, but if you unfix this and try to move it around, the whole thing freaks out. You see how everything is moving? We don't want that. So remember to fix a part to your assembly. So always fix a part. So that is the slider mate. And there's a few nuances with stuff like the slider mates or rotation, revolute mates and all these things that we'll go through later. But you really want to worry about limits right here. Now this essentially, the limits sets how far or the minimum and maximum distance that this object should be positioned, or the range of motion, sorry. That might be a better way to describe it. The limits dictates the range of motion that these two objects have. So in this case, if we include a minimum, say 10 millimeters, or this is 10 inches, 10 millimeters right here. Ooh, you know what? Let's switch this back to millimeters because that is horrendous. I hate inches. So instead we do say like 30 millimeters. And you can see that this Z has increased by 30 because it has, that is the minimum distance in which it has to start in. So if I try to move it back, it cannot exceed 30 millimeters from that first mate connector where it was aligned. So as I try to move it, it's going to get stuck. And so this is a very useful constraint sometimes when you're making things you don't want to over rotate and things like that. And same goes for the maximum. If I want to include 100 millimeters or maybe 70 millimeters as my maximum, you can see that the part can no longer slide more than 70 millimeters away from the original mate connector. So there you have it. So limits is a really good, useful way to actually constrain your parts in your assembly. So next, we're actually going to assemble the handle. And so the handle, remember, click on the canvas and then press check. And now you can see if we pull everything apart, everything is going to be, everything is very random. So, I mean, it's not connected. So there are a few more mates that we want to go through. So first, we're going to use the fasten again, right again. We're going to go right into this handle. this interface right here so that it's sort of like plugged in. Press Shift to select the face, and then click. Press and hold Shift on here as well. So we want this face to be attached to this mate connector. So we're going to hold Shift. I'm going to press and we're going to click, and it's going to solve it for us. It looks like that. So we're going to press check, and there we go. That part is now fixed. We can move it around and nothing's going to happen. And next, what we're going to do is this part actually goes within this hole right here. And so this is actually going to be a cylindrical mate, because instead of just sliding in and out, it also can rotate. And so you can think of this mate as sort of a screw. It's sort of it can rotate sideways as well as slide up and down. So right over here, you can see that this face, that rounded edge, it's not going to be able to be selected, but we can select the next, sort of the inner circle right here. And we're going to press Shift. We're going to select that. Now you can see if we rotate around, you can see that this is actually the mate connector that we selected right over here. And so next, we will select this mate connector because we want this to we need this to slide into this hole. So we press Enter. We can see that keep track of this hole, because look, when we move it up and down, it's twisting sideways, but it also can go through, as you can see. And this is like right here is a perfect example why we need limits, because in reality, we wouldn't want this to sort of pass through. You can kind of see that the simulation is sort of failing. One of the parts is sliding all the way through. So yes. So remember your dimensioning tool from last time that we used. It's really useful. If you press the dimension tool, it'll show the pop-up. And here we're going to select this line right over here and this edge right over here. And so we want to look at the center distance right here. So this is basically saying if we hover over it, it's 100.521 millimeters long. And so by adding this as our maximum constraint, and you see why it might be a little confusing right now, but if we add our limits and our Z, this is up and down, we're going to add this maximum, 100.52131. If you take a look now, if we try to slide this down, it's actually going to max, it stops right at that maximum point. So we just use the dimension tool to measure the distance, the horizontal distance from this line to this line. And afterwards, after we use that dimension, we added that as a constraint. So now it can no longer push through that part. It only slides through like this. Next, we have, this is our final mate that we're going to introduce, and it's called the ball mate. And so the ball mate sort of interacts with these sort of curved faces and allows for 360 degrees of motion. So we're going to select this mate connector right over here. As you can see, it's a little finicky, but if you press Shift, it might right there. So I'm going to select this, and we're going to select this curve right over here. I'm going to select the face right over here. Let's see if this works. Let's see if that works. And it should allow us to rotate this pretty freely. Exactly. And now that ball mate kind of works. It kind of works. But now, like you said, we can sort of set those limits again. The angles can be set. So we can probably do like, let's just say let's do 180 as our maximum. So if we try to rotate it another 180 degrees, it will be locked in that zone, if you can see that. It looks a little finicky, but I don't really use the ball mate very often either. So I suggest you simply go in and just test it out yourself. But anyways, after using the ball connector, and you can sort of mess around, there you have it. You have a functioning clamp that works. So this, remember, the fasten tool helps us, secure parts together so these don't move anymore. Remember to fix a part to your assembly so everything is sort of still and in relation to one another. And when you want to move something, the rest of the parts to do should stay still. Next, we use a cylindrical mate right here that rotates sideways as well as slides up and down right over here. And there's a slider mate down here that moves up and down again, and the ball mate that allows this piece to move 360 degrees. And you can see that I didn't really apply that constraint, but I just feel a little lazy. So there you have it. This is how you do basic assemblies in Onshape. and using your mate connectors to your advantage. I suggest that you sort of explore these other ones, like your Revolute mate. It sounds like what it is. If you connect um, two parts, it will rotate around the z-axis. The planar mate allows you to move across a plane, like it said. And there are other mate connectors that I usually never really use, but I hope this is a good introduction to some basic mate connectors. And we made this little clamp right here. So yeah, let me know if you have any questions, and thank you. Yeah.